Hi, Vicky.
Hi, Shane.
What did you want to be when you grew up? I guess, are we grown up yet? When you
No,
were a kid, what did you think you wanted to be when you grew up?
I think you can always have a what do I want to be when I grow up, no matter how old you are. But
Oh, sure. No, I'm totally I'm on board with that.
yeah, but when I was a kid, I think I wanted to be a lawyer, an environmental lawyer.
How much of a kid are we talking about here? What age do you think this happened?
Probably like high school
Were you 6 years old and thinking, you know what I want to be when I grow up? I want to fight environmental justice via the law
with my briefcase or with my
with your briefcase.
satchel. Um, no, I guess it must have been older. I can't remember if I wanted to ever be anything like a ballerina or anything, classic fire person, classic little kid stuff.
Yeah, the stereotypes, I guess.
Yeah, but an environmental lawyer fighting the good fight.
When did that dream die for you?
Oh, it's funny you should ask. Um, I don't know. I just didn't want to do it anymore. I found nonprofits and I wanted to work. I just changed what I wanted. But my parents think that I stopped wanting to be a lawyer. I got into a pretty bad car accident when I was in college
Oh,
and then had
geez.
to go, yeah, everybody was fine.
Okay.
But then I had to go through all of this legal mumbo jumbo. You know, about it. And my parents think that that was the moment that my dreams were
You
crushed.
just thought, never again.
Yeah, but it wasn't. It wasn't, or not that I feel, but yeah, I just kind of naturally switched gears. Yeah. What did you want to be?
Oh, I had no dreams. Absolutely no dreams whatsoever. Maybe we're just boring like that.
That's okay.
Um,
We're here now.
well, sure. Yeah, we're podcasters now. Who would have thought, right?
We're fine. We're doing okay.
Well, so we are talking about this because I know that a lot of folks, you mentioned ballerina or firefighter,
Mhm.
but a lot of folks want to be an astronaut when they grow up.
Oh, yeah.
And wow, it doesn't seem like that was either of our dreams.
Mhm.
Our final mini series of 2022 that I guess I have to put an asterisk on that will actually air mostly in 2023 because scheduling is the way it is. uh, we're doing great today. But the series will actually feature interviews with NASA scientists from all sorts of backgrounds, frankly, not just space.
Oh, that's really cool. I'm excited to hear about all the different types of people that work at NASA.
Yeah, and so for this episode, we're going to hear previews from episodes in the series that we're calling Spaceship Earth. Our interviewer was Ashely Hamer, and I hope you all enjoy. Science is fascinating, but don't just take my word for it. Join us as we hear stories from scientists for everyone. I'm Shane Hanlon.
And I'm Vicky Thompson.
And this is Third Pod from the Sun.
So my name is Chris Justice. I'm a professor in the Department of Geographical Sciences, University of Maryland. At the moment, we're involved in an applied sciences program with NASA on agriculture. It's NASA's agricultural program called Harvest. So this is taking NASA satellite data and the science that's been developed around that and making it useful for societal benefit. Working on food security in Africa, working on the crop production in Ukraine, working on new methods for extracting information from satellites on crop production and yield, and looking at the major producing countries around the world, the grain producers for the commodity crops, and looking at shortages and if there's drought and if there are problems in agricultural production, and then what the impacts are on the global market and the impacts on supply chains that we've been experiencing. It's really the only way of figuring out what's going on and trying to give some early advance notice of drought and sort of food security issues in parts of the world which perhaps don't have the same monitoring systems that we do here in the US.
My name is Dorian Janney, and I work for NASA at Goddard Space Flight Center. I work for a contractor called ADNET, and I am the Senior Education and Outreach Specialist for the Global Precipitation Measurement Mission. When I had begun teaching, Pluto was a planet. And then during my teaching, Pluto was demoted. And I had a colleague come in to me and say, "I'm so sorry. I heard about Pluto when I was teaching." And I remember saying to her, "Oh, this is so exciting. This is how science works. Pluto doesn't care. Pluto's still there. Pluto still is recognized as a super important component of our solar system. But what's happened is that we've broadened our understanding, utilizing more sophisticated technology, and that's just forced us then to need to come up with a new conceptual scheme. So I'm saying all this to say that some of the challenges we have as scientists and science communicators are that when we are trying to help the public understand things, we have to find ways to make it understandable, and we also have to help with this narrative that yes, sometimes science is going to change. It doesn't mean that the facts are going to change. It doesn't mean that nothing can be believed because everything's going to change. So it's a complicated and challenging road to walk in helping people to know that yes, there are facts in science, and yes, those facts will change, but that doesn't mean that things aren't real, that we don't know what we're talking about.
My name is Dr. Matthew Rodell, and I'm the Deputy Director of Earth Sciences for Hydrosphere, Biosphere, and Geophysics at NASA's Goddard Space Flight Center. One of the things I'm most proud of is I was one of the first GRACE hydrologists. GRACE is the Gravity Recovery and Climate Experiment, and it's a satellite mission. NASA has, about 20 missions in orbit right now. Most of them are looking down and making measurements, various wavelengths of the EM spectrum, and turning those into useful observations for hydrology or for other areas of Earth science. GRACE is completely different because it's actually two satellites that are orbiting the Earth together, and instead of looking down, the key measurement is the distance between the two satellites. And the reason that's important is because as satellites orbit the Earth's gravity field is not completely homogeneous. So if you think of where there's a mountain range, there's more mass there, and that means there's more gravitational potential. And Earth, as satellites are floating around, basically in a vacuum, their orbits are affected a little bit by the shape of Earth's gravity field. And so GRACE, using the measurements of the distance between the two satellites, along with their precise positioning, basically are able to measure the perturbations of their orbit caused by variations in the gravity field. And so each month of observations can be used to create a new map of Earth's gravity field. And from month to month, the maps are so precise that we can see changes in the gravity field. And the main cause of those changes are redistributions of mass at the surface, so things like groundwater, soil moisture, surface water, and snow and ice. And as those are redistributed around, it's large quantities of mass. It's enough to perturb the orbits of satellites, and so we can back out based on the GRACE data. Basically the amount of snow that must have fallen in order to cause that change in the gravity field.
My name is Concha Reed. I work for the National Aeronautics and Space Administration at Glenn Research Center in Cleveland. I am the Deputy Program Manager for NASA's Radioisotope Power Systems Program, and this is under the NASA Headquarters Science Mission Directorate and the Planetary Sciences Division. I grew up in a really small island, St. Thomas in the Virgin Islands, and there's not a lot of, let's say, light pollution there because it's a very small place. And at night, it can be very, very dark. And so the stars were within reach when I was growing up. And so, like a lot of young people, I used to look up at the stars and just kind of dream about what's out there. And then a few things naturally occurred during the course of growing up. I studied power engineering in college. So this is a portion of electrical engineering. So growing up, because again, being a small island, we didn't have the benefit of a lot of backup power like places in the United States have, for instance. And we fell victim to hurricanes a few times during my young life. And so we sometimes would go long stretches without having electrical power. And I just kind of always wondered, well, are there things that I could do in the future to try to make sure that we have a more reliable source of power? And this kind of also drew me when I was in my high school years, for instance. I was very interested in math and science. And I had a really wonderful chemistry teacher who also happened to be my physics teacher, and just had a natural love for teaching and for educating young folks. And all of these things helped to inspire me to, study electrical engineering and science in college.
My name is Mark Subarow. I work for NASA's Goddard Space Flight Center, and I lead the Scientific Visualization Studio. So it's basically turning science into movies. The team uses a lot of the same software and visual effects software that Hollywood uses. So we have one foot in that world, but at the same time, we have to be able to understand, and it's all different kinds of science: earth science, planetary science, heliophysics, astrophysics, and be able to speak the language of science as well. Like the really big concepts are, in many ways, often the easiest things to understand. I'll give an example from astronomy. So there are a couple things that people always ask about in astronomy. It's black holes. Well, black holes are just cool in the public imagination. But interestingly, a lot of it, the topics people ask about are cosmological and like really big things like the origin and evolution of the universe, which seem like really, really advanced science. And you might say to yourself, well, people don't understand how seasons work. Like, if they don't understand how the seasons work, why am I explaining to them about like redshift and the expansion of the universe? But if you actually stop and think about it, an expanding universe is an easier mental concept than how the seasons work, which is actually a lot of complex geometry, which is actually hard to piece together. It's just that it seems like it's simple because one's far removed from our experience and one is our everyday experience.
Hello, my name is Krista Peters-Ledard. I am currently the Acting Director for Sciences and Exploration at NASA's Goddard Space Flight Center. Science is the R&D for the future, right? So we learn about our universe, but ultimately we also, as we explore this universe, I mean, we're understanding, not only really fundamental questions about, where is life, how did life evolve? How did our universe evolve? But also, I mean, we are understanding the abundance of different elements. I mean, ultimately we might understand, how different planets have evolved and how they've supported life, and we might be able to bring it back to supporting life on Earth, right? So, I mean, this Earth, Earth 1.0 is here, but Earth 2.0 could be out there. And so, imagine knowing our place in the universe and how we can have, a sustainable path towards, intelligent life, going forward? I mean, these are huge questions. I mean, the other thing that's happening right now is that the private sector is revolutionizing access to space. So I think it's like an exciting time, but it's a little uncertain, because what is NASA's role in that? How does NASA help facilitate these partnerships and, maintain a focus on the big questions, while, also partnering with the Earth and space sector to advance this new economy? I mean, there's going to be a new space economy. And how do you protect the science? So that's, I think, a big challenge we're going to have to navigate as we move forward.
So I think something that a lot of folks don't realize is that there are a ton of scientists at NASA who don't do anything related to space.
Yeah, definitely. I honestly didn't know that, and I'm excited for folks to hear from all sorts of NASA scientists over the coming weeks. And with that, that's all from Third Pod from the Sun.
Thanks so much to Jason Rodriguez and to you, Shane, for producing this episode.
And to Collin Warren for audio engineering, with artwork by Karen Romano Young.
We'd love to hear your thoughts on the podcast. Please rate and review us, and you can find new episodes on your favorite podcasting app or at thirdpodfromthesun.com.
Thanks all, and we'll see you next week.
I literally can't. There's like certain things that if you say them out loud, I just start thinking boop, 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 ba-doop, boop, ba-doop, boop, like the little music.
Oh, yeah.
It's like when you memorize an
Thanks
album.
all, and we'll see you next week.
Yeah. I guess people don't really do that anymore, memorize an album. Do you remember doing that? Like you would play a CD or play a cassette tape, and then if you heard a song on the radio, you would instantly start thinking of the next song that would come on the album.
Oh, sure. Yeah.
But I guess, is that a thing still for most people?
Yeah.
I don't know.
Probably not for most people, no. I mean, not even for me. I listen to a lot of music, but I can't tell you the last time I listened to an album.
Right. Like just straight through.
Yeah. We're boring. I'm boring. I'll say I'm boring.
No, I'm boring. I'll take it.